Good afternoon, everybody. We all know that sandy soil is a big challenge for Australian agriculture because this soil has different poor properties and also very low content of soil carbon. So to improve these properties, we commonly rely on external materials as amendments with its organic and inorganic forms. We know amendments increase bulk soil organic carbon in soil, but we actually don't fully understand how these amendments influence carbon retention and which strategies work best for the long term. So to address this research gap, in my PhD research, at first I optimized a method to analyze the carbon compounds in soil. Then I applied this method to investigate the short-term carbon cycling in amended soil, which are collected from 73 days for trial. And in this for trial, amendments are used as pelletized form. Then, finally, I set up another 6 months for trial, where I used organic and inorganic amendments alone and also in combination. So from my preliminary result, I found that pelletized compost's effect on short-term carbon compound cycling started significantly after 3 months, with gradual enhancing of microbial processing and transformation. Then in my next study, when I added hydrochalcite, which is a special type of clay and has unique surface chemistry with compost, then I found that this combination of amendment strategy showed a uniform soil cycling in between two carbon soil profile within 0 to 20 centimeter in the soil. That means co-applying of hydrochalcite with compost can be a potential solution for to reduce rapid carbon loss. But we are suggesting a longer experimental period to see the actual effects of this complex amendment strategy. If I translate my data from research to real world, then I can summarize that pelletized amendments can be more beneficial for long-term carbon stabilization. If we apply these amendments at a specific depth in soil with seed, and also it become more effective with plants during the growth than the fallow. And compost benefits are time dependent, and these benefits increased more in terms of long-term carbon stability and nutrient retention if we can use with the combination of hydrochalcite. So the take-home message from my research, like for researchers, we have now a method for carbon compound analysis, which is very fast and eco-friendly, and also suggestion to set up the experimental period for longer. For farmers and growers, my research provides conditions to enhance active soil carbon cycling. That is very important indicator for soil health with organic and inorganic amendments combination. Also, in agribusiness, there is an opportunity to produce pelletized products, and there is policymakers can support a data-driven amendment strategy to improve sandy soil health. Okay, so until this point, I can say my research actually have planted as a seed, but we need more support. We need more time and finding to make these findings into practical field-ready solutions. Thank you all.